All right, welcome everyone. It is my pleasure to introduce Charlotte Zito, who's going to present today a talk in the seminar series of Geneva, the Geneva Symmetry group. Charlotte did her BA and MA at the University of Milan, the State University of Milan, and is now in the MA program in philosophy at the Università Italiana in Milano. And we're happy to hear her talk today about string theory and trope theory, the hypothesis for the interpretation of the properties postulated by physics. Please, Charlotte.
Okay. Yes, thank you for the kind introduction. So, hi everyone. Chris already read the title of this presentation. Before starting, I would like to make two disclaimers. So the first one is that this is a work in progress, and it's a work in progress that has just started. So this is just like a way to introduce you something I'm working on. So nothing I'm going to tell you is like definitive or something like that. I'm here just to receive your feedback, have some suggestions maybe on what I could do better. So something like that. So anything you would like to say, it's more than welcomed. The second disclaimer is that we are going to talk about string theory, but I'm going to talk about this only from a phenomenological point of view. So I'm not going to use any formulas. First of all, because I'm not able to do so. Second, because I don't think it's actually what I need at this stage of this research. I mean, we can do things even without using formulas. So having said that, we can start. First of all, I would like to show with you the index of the presentation, so to show you the whole structure so that nobody gets lost. So I will first of all introduce you string theory, actually very briefly. So I'm going to point out the main claims of the theory and some of the problems involved within these physical approaches. Then we are going to talk about metaphysics. So we are going to see which the main claims of trope theory as opposed to the theory of universals. So these two are metaphysical approaches to properties. So we are going to talk about metaphysics of properties. And we will see that these two metaphysical approaches are one against the other. After that, we are going to investigate some of the attempts which have already been made within literature to defend trope theory through physics. And so this point was actually very important for the beginning, for the starting of this presentation, because as we started to talk about trope theory at USI, we started asking whether this kind of metaphysical approach could be defended through physics. And it came out that there were already different approaches to that using physical theories. So yeah, we are going to illustrate all these different approaches. After that, we are going to put together string theory and trope theory. And we are going to see that a defense of trope theory using string theory can be done in two different ways. So first of all, the first kind of approach is to see the string as the fundamental trope of reality. So maybe this is more the more trivial approach. But then we also have another option. So we could take Calabi-Yau spaces as the starting point. And this is maybe not very trivial to do. And we will see that there are some problems related to this second path we can endorse. And after that, we will conclude with some remarks about the whole presentation. Okay, so let's get started with string theory. So string theory describes a universe as made of strings. So strings can be thought as very tiny filaments, so we are talking about Planck's scale. And these filaments can be like the laces of your shoes, so they can be open, like this blue string here, but they can also be closed, like this green string here. And the point is that these strings vibrate, which is kind of represented in this image too. So we have the string and its vibration. However, string theory also postulates a universe made up by extra dimensions. So we have, according to relativity, 4 extended dimensions. So we have here, the 3 dimensions of space. We have the 1 dimension of time. But string theory also postulates other 6 dimensions. So we end up with a total of 10 dimensions. Even though this number is actually a little bit controversial, there are some physicists who postulate extra dimensions other than these 6 we already have here. But I mean, this is not important for the goal of this presentation. What is important is that these extra dimensions are explained using Calabi-Yau spaces, which are geometrical spaces which have very particular configurations. So basically, we are talking about tori. Tori are this kind of shapes within geometry. So they are like spheres with a hole, so like donut. And these tori can be put together and they can be deformed. And we will see that this deformation of Calabi-Yau spaces is very important within string theory because it explains something about strings. However, one might ask, where are these 6 other dimensions? Why nobody has ever reached them or experienced them? Well, the thing is that these extra dimensions are, first of all, very tiny, and they are like rolled up. So we are insensible to those dimensions. We cannot possibly reach them. We are 4-dimensional entities, so we extend through space and through time. So through these 4 extended dimensions already postulated by physics of relativity, but we cannot possibly have access to these 6 extra dimensions. It's like, I don't know if you have ever read it, but there's like this novel, Flatland, by Abbott. I don't know if you know about it, okay. So in this novel, there is this square, and squares are geometrical figures which exist only in 2 dimensions. So this square is the protagonist of this novel, and it is explained that this square, given that it's in 2 dimensions, cannot possibly even imagine further dimensions of reality. So he doesn't have access to further dimensions. He can only imagine worlds with less dimensions, but not higher order dimensions. And the same happens with string theory. So we are human beings living in 4 dimensions. We cannot even imagine a world with 10 dimensions. That's basically the general idea. So, but there are some problems with string theory because it appears a little bit controversial. I mean, it's weird to imagine a universe made up of 10 dimensions. And indeed, those problems are related to the fact that there are no experimental corroboration of the theory. So we cannot even possibly make experiments on those extra dimensions. We cannot even make experiments on the strings because they are too tiny for our technical experiments. So we cannot even access them in this respect. We can only hope to have like indirect verification of the theory, which we are still waiting, by the way. So there is no experiment which has ever corroborate string theory. However, why is string theory so important within physics? Well, because it has some explicative value. And indeed, I've told you before about the vibration of the string. Actually, the strings vibrate within Calabi-Yau spaces. So we have these donuts, and inside the donuts, and actually also around the donuts, strings can vibrate. And this vibration of the string is very important because it determines the different characteristics of the particles. So for example, here we have the mass, the electric charge, and the spin. And according to the standard model, each particle is actually defined by those numbers. So for example, here we have this table, and we have the three families of particles. So for example, here we have leptons, bosons, which are responsible for forces, and here we have quarks. And as you can see, each particle, each kind of particle has a different connotation of spin, of charge, or of mass. So if we so here we have the mass, which is different. So we have the quark up, whose mass is different than in respect to the quark charm. And the same goes, for example, for electrons, muon, and so on and so on. So all the particles postulated by the standard model can be differentiated using these numbers. And string theory actually can explain why we have only three families of particles thanks to the vibration of the string within Calabi-Yau spaces. Okay, now for the metaphysics part. So trope theory is a theory about properties. So actuording to a tropist, reality is wholly or partly made of tropes. So maybe there are some tropists who thinks about reality made of tropes and maybe also some other entities. But in general, yeah, reality is wholly or partly made of tropes. And tropes, as you might already know, are particular properties. So for example, we cannot talk about blackness in general. We can only talk about, for example, the blackness of this particular chair. And tropes can be conceived as concrete or as abstract entities. However, in this presentation, I'm just going to conceive tropes as concrete entities. And there are some claims which the majority of tropists make. So tropes are irreducible. So there's nothing smaller than tropes. So tropes are the fundamental entities of reality. There's nothing else than tropes. Objects are bundles of tropes. So objects are conceived as mereological sums of tropes. Tropes are identified by their spatiotemporal location, and we will see that this characteristic is a bit controversial, so there are some problems related to that. And tropes have causal powers. However, in general, I think that the trope theory approach is like a bottom-up approach, because we postulate a reality with tropes, which are like the smaller, the most fundamental entities of the universe, and from that we build up objects. So objects are mereological sums of these tropes. The opponent view is the view that postulates properties as universals. So properties, according to this approach, are abstract entities. Properties are exemplified in material objects. So for this kind of approach, it actually makes sense to speak about a general blackness. So a blackness as an abstract general things that all the black material objects exemplify. And this approach is more like endorse a top-down relation between properties and material objects, because we have the properties. For example, think about the Platonic world. We have properties, and then we have material objects. However, this kind of approach has some problems. There are actually many problems, but the one I'm going to focus on is the problem on how to explain the relation among material objects and abstract entities. Because if material objects exemplify properties which are conceived as abstract entities, then we should be able to explain this duality. And it's actually not very easy to do so. One of the solutions endorsed by universalists is to explain this dualism between something abstract and something concrete in terms of participation. So material objects participate of the same abstract property of, say, blackness or redness. However, one objection that could be made against universalists is that it's against ontological parsimony, which cannot be said instead of the tropist approach. So the tropist approach, especially if we conceive tropes only as concrete entities, is ontological parsimonial. So on the other side here, we have both abstract entities and material objects, so it's against ontological parsimony. Okay, now tropes and physics. So we are going to analyze some different attempts to use physics in order to defend a trope theory. So the first attempt is related to Campbell's works. So Campbell postulated a field theory of tropes. So he basically said that the basic forces of physics, so gravitation, electromagnetism, the weak and strong nuclear forces, are the basic tropes. So we should start from them, and then we get material objects and the universe and etc. The main objection against Campbell's approach is that, there are actually two objections. The first one is that field theory is not mathematically, it's not like precise from the mathematical point of view. And second of all, within field theory, we cannot actually say precisely where the material objects or the tropes are located. So, and as you might remember, we have said before that tropes have to be spatiotemporally located within a general trope view. But yeah, Campbell's approach doesn't respect this point. After Campbell, we had Simons and Morganti attempt to defend trope theory through physics. So Simons, they share the fact that according to them, tropes are the particles of quantum physics. Simons postulates a nuclear theory of tropes, but they are practically the same in the sense that according to them, the fundamental particles are bundles of tropes. So we have seen that fundamental particles can be identified by certain values of spin, mass, and electric charge. And yeah, they both agree in saying that these are the fundamental tropes, and that the particle postulated by the standard model are bundles of these tropes. More recently, we have Aldo Frady, which takes into consideration relational quantum mechanics. And yeah, his reasoning is actually very similar to what Simons and Morganti say, because he simply adds relativism. So he says that quantum states are mereological sum of properties which are observer dependent. So it's like to add to quantum mechanics a relativistic approach. That's why it's called relational quantum mechanics. So these sums of properties are observer dependent. So two different observers observe different sums of properties, but their descriptions are equivalent. Okay, now we should try to put string theory and trope theory together, because within these approaches there is nothing about string theory. So string theory, nobody has done something to connect string theory and trope theory yet. So, as I have already mentioned to you, there are two different approaches, two different options one might endorse. The first one is to conceive the string as the fundamental entity. Since, we have already seen that the vibration of the string determines the characteristics of the particles. So, according to this approach, we could consider strings as the fundamental tropes, because the strings and their vibration could be considered as a single trope. And this approach, I think, is more similar to what Simons, Morganti have done, and also Dofredi have done, because instead of considering particles as the fundamental tropes, we are considering strings as the fundamental trope. So I haven't formulated yet a whole theory based on this kind of approach, but I'm confident that something could be done if we endorse strings as the fundamental tropes, but I haven't worked out all the details yet. However, there's a less trivial approach we could try to endorse, but it's also more complicated, because we could consider Calabi-Yau spaces as the fundamental entity of reality, because as I've mentioned you before, strings vibrate, but they vibrate inside, so within Calabi-Yau spaces. So actually strings are not fundamental. It's the geometry of Calabi-Yau spaces that it's fundamental. And moreover, the strings vibrate according to a certain arrangements of the holes of Calabi-Yau spaces. And therefore, the variety of Calabi-Yau spaces determine the vibration of the strings. And there are actually 1,000 kind of variety of Calabi-Yau spaces, and they all determine a different kind of vibration of the string. However, this might result controversial, because it seems that we are back to a dualist ontology, because here we have Calabi-Yau spaces on the one side, so we have this geometry that describes the universe in which the strings vibrate, and on the other side we have strings and their vibration. So it seems like, that we are back to a dualist approach to metaphysics, which is something I wanted to avoid in saying that I didn't agree with the universalist approach towards properties. And it's also against ontological parsimony. So, the problem is therefore to explain the properties of the elementary particles in a uniform way, and see if this kind of option can be endorsed, and if yes, how. So avoiding the duality I do not want to endorse. So one option might be to endorse supersubstantivalism, which has also been called the identity view. Schaffer has done some work on that. So basically, substantivalism is a metaphysical view about the structure of space-time, and it basically says that the structure of space-time is a sort of substance. So we are not actually inquiring which kind of substance space-time is, we are just saying that space-time is a sort of substance. And therefore, we might ask whether material objects are a second sort of substance in respect to space-time. And the supersubstantivalism says that no, material objects are not a second sort of substance with respect to space-time. So they are in some sense identical. So we cannot actually distinguish material objects from space-time. they are like the same thing. This might be a little bit controversial, so there is still work to be done on this. So basically, we could endorse the identity view together with a bundle theory of trope. And we could maybe consider that there is no distinction between Calabi-Yau spaces, the string, and their vibration. Because if we assume super substantivalism and we like try to identify these three entities, or yeah, these three entities, we do not actually end up with a dualist ontology, because we are assuming that they are identical. So we have solved our problems. However, this is only just an option. It's like just a way this problem could be solved, but it's not definitive. I mean, I still have to work on this, even because I don't know if it is possible from the physical point of view to embrace this kind of solution. Yeah, so we could consider the triplet made of space-time, string, and vibration as the single trope that makes up the object. So we have this trope that characterizes the different characteristics of particles, and from that we build up objects. However, there are some possible problems related to this. So can we actually apply supersubstantivalism to string theory? This might be a little bit controversial, because do Calabi-Yau spaces include space-time? I mean, Schaffer applies the identity view only to the theory of relativity. He doesn't actually defend the identity view through string theory. So this first point has to be further addressed. And furthermore, Calabi-Yau spaces are geometrical spaces able to account for the extra dimensions we need in order to have particles of the standard model through strings. So Calabi-Yau spaces are geometrical spaces. They are something different in some sense in respect to the space postulated by relativity. So I don't actually know if it is possible to apply supersubstantivalism to string theory. So for sure, further research has to be done in order to investigate the link between Calabi-Yau spaces and strings and their vibration. Because at the beginning, I thought that within string theory, it would have been impossible to like even imagine a string without its vibration. I mean, I don't know if strings can not vibrate within Calabi-Yau spaces, because I've read this analogy between the conformation of Calabi-Yau spaces and like the floor of the ocean. If you think about it, nearby the shores, the floor of the ocean is fundamental in order to determine, I don't know, the height and the shape of waves. And the same happens with the vibration of the strings. So Calabi-Yau spaces really determine the vibration of the strings. But can we imagine an ocean without waves? I don't think so. So maybe the same can be applied to string theory, but I don't know. I mean, I still need to do further research on that. So this brings me to the conclusion. So I just want to recap what we have done. So we have started with string theory, and we have tried to directly apply a bundle trope theory to that. So this was the first approach we could endorse by considering the string as the fundamental entity of reality. We have tried to apply supersubstantivalism and trope theory to string theory. We could end up with an ontology in which objects are indistinguishable from space-time. But however, I think that the main conclusion is that a lot of work has to be done in this direction. So, thanks.
Thank you very much. Well, that's super interesting. I think that's a great project. I mean, as Alison said last week, I think I have 20 questions, 20 comments.
Starting first.
I will start with the
Start
first.
with the seventh. I mean, it's hardly.
Yeah, okay.
Okay, why not?
The
Okay.
seventh, yes.
Okay. So the second comment is that I guess I have two very major remarks. I guess the first one is that I guess in order to understand how we are going to think about properties in string theory, whether tropes or universals, the problem of properties, we kind of need to solve the problem of space in string theory and to know what is space according to the theory, right? So you mentioned Calabi-Yau space, Calabi-Yau spaces. So in fact, so you have a problem is that in some description you have a 10-dimensional space, right? And in other description you basically break it down in two parts, like a background structure and 6-dimensional Calabi-Yau spaces. But it's not clear at all what is space. And for instance, you talk a lot about Calabi-Yau space, but you didn't really talk about the other dimensions, the rest of the dimensions. For instance, if you want to be super substantivalist, are you going to be super substantivalist about the 10-dimensional space-time, just the fibers, something else? So I guess one thing interesting to explore would be how we are going to think about space and space-time string theory to be able to describe properties. And one important point in the direction that how do you define universals? Well, you need a primitive notion of multi-location. But to have multi-location, you need location. To have location, you need space, right? So if you want to have a super clear story about what's going on, you will need to look at different models of space and space-time in string theory. And I mean, it's very open at the moment. There is no clear metaphysics of space-time in string theory at the moment, or like attempts to get a sense of what's going on. Yeah. So I already spoke a lot with my second comment, so maybe I'll stop here from there.
No, this is actually, I've thought a lot about it. I mean, it's not clear how string theory think about space-time, or at least it's not clear for me. And indeed, there's still a lot of work to do in that direction because, yes, as I said, string theory postulates a universe of 10 dimensions, but I mean, those 10 dimensions include space of relativity, space-time of relativity, but those 6 extra dimensions, it's only there where Calabi-Yau spaces work or happen to be. So, yeah, there is still a lot of work to do in that direction. Even because, I mean, Schaffer applies supersubstantivalism only to the dimensions of relativity, but not on the 6 other dimensions postulated by string theory. So I have doubts about that too.
I'm also trying to make sense of what's going on, and one possible direction to go is to look at classical gauge theories, because there you also have simpler models where basically it's a formalism used in physics, where you think of properties in a space as some kind of features of additional space called the fiber spaces that kind of live on top of the background space. So it may be interesting perhaps before moving to string theory to try to clarify the ontology there. I mean, as Joshua and Lorenzo made me aware recently, there is a work of Frank Artsenius that try to be to define a kind of realism about those other spaces, and that might be an interesting direction for you if you want to go in that direction.
Yeah, sure. I mean, I know nothing about gauge theory, so this will be something completely new. I have just heard about it, but yeah, thanks. Thanks for the suggestion.
I'm happy to ask later a second comment if there is time, but probably I should let the others speak.
Okay, yeah, before I start, I texted both Morgante and Montefredi, just so you know.
What?
And they already replied. they're honored that you're talking about that. But God is a little bit skeptical that you put in. It's the same thing with silence, but still. I didn't capture your picture at all. It's just the slides. No, so thanks. That was great. So instead of actually, I can't press some objections, but I'm just gonna suggest something. Okay. So there is one guy that already did a bunch of work in a thing you're interested in. So it's unreadable, Maria will tell you that. So it's Daniel Giberman. So this is a metaphysician that has worked exactly on trope theories and supersubstantivism. He just came up with a paper which is called super-tropstantivalism. I know.
Okay.
I know. But it might be nice for you because so one thing that it seems weird when you set up the first thing is that in the case of Simons and Morganti and Campbell, all the things, what they really did was identify object-like entities with bundles of tropes, which were property-like entities. There seems to be like string, as you said, it doesn't sound as a property-like entity, it sounds like an object-like entity. Same for spaces, whatever. Just go with the topological space. So you mentioned yourself, right? So the topological properties of the spaces, just take that. And there is some work in metaphysics that has been already done.
Okay.
So you might actually take it and see whether, I mean, this is nothing to do with string theory. Of course, it's just classical supersubstantivism. But it's a nice place to start instead of, just figuring things out by yourself.
Yeah.
There is a work that is already being done. And once again, Maria can tell you, because we've been reading things, it's really difficult to read that guy. Like, it's not clear, at least he's not the most clear writer. But you have.
But you should cite it.
Well, it was my referee for a paper against supersubstantivalism, so I had to cite him. That's why I read the paper. But there is this thing. And so the other suggestion would be, for the entire project, I think it would be great if you could do these two things. So, as you mentioned, there are several problems about just metaphysics problems about trope theories. There might be some physical problems about string theory. I don't know anything about this. I just know that there are strings. It would be nice if you could show, for example, that moving the application to string theory perhaps solves some traditional problems about tropes. So, for example, one traditional things that I think physics solves for trope theories was methodological bundle theories, for example, right? They had to come up with restricting composition. They cannot just sum up whatever they want, right? Because you otherwise you will end up, having something that's blue and green, and you don't want
That's
that.
USI's view.
Exactly. So you don't want that, right?
Mm-hmm.
But it's very hard to come up with good restrictions and compositions. If you have that view, physics tells you, for example, well, you shouldn't sum up properties that don't commute. So quantum mechanics, for example, the application. On the other hand, though, there's going to be problems coming now, because chances are, how are you sure that if you sum up quantum properties, you get symmetric composition? And if you don't get symmetric composition, you don't get symmetric parting. And if you don't get symmetric parting, you get a very weird mereology. And if you get a very weird mereology, is your theory, it's mereological bundle theory even worth it? But it's good to see whether there's some problems here in the metaphysics that maybe the application for physics can solve, right?
Mm-hmm.
On the other hand, perhaps, hopefully, for us metaphysicians, it's good that sometimes if metaphysics can help some problems
Related to physics.
it would be a great addition to the project, which seems already great.
Yeah, thanks.
This is just a suggestion.
Thanks a lot.
I have a question. And it's a sort of a methodological question. I was not fully clear what the methodology of the project is. Is the idea that we're trope theorists and we hold fixed trope theory as our key to understanding properties, because understanding properties as universals has this unwelcome consequence apparently of dualism and maybe bloated ontology, which if we do trope theory, at least understanding tropes as concrete entities, then maybe we can avoid that kind of dualism. And then, because we want to keep up the banner of trope theories, we go to physics for support. How could we find support? Because we're good naturalists after all, so we think true support for a metaphysical theory will come from some sort of fundamental physics. And then, yes, we find string theory, and maybe, you know, this could add support to our already, you know, sort of initial position we've had.
Yeah.
Or is it rather that we don't have any committed view on the metaphysics of properties? Instead, we're philosophers of physics. Our job is to look at physics, to interpret physical theories, to try and understand what they tell us about the world, and so on and so forth. And then we come to this really puzzling new theory of string theory, and we think like, you know, we take out our toolbox with all the metaphysical tools, and we find, trope theory, maybe that's going to work there. Is that the methodology? Or is it more like maybe along the lines Claudio suggested, that what we're interested in is just sort of exploring combinations and options and the space of theories and of sort of packages of where we could fit together things? How do you think of the project?
So when I began to work on this stuff, I first started to assume trope theory like, okay, I have to defend this metaphysical approach toward properties because at least intuitively, I think that it's the best metaphysical approach toward properties. But if I have to conceive this project like as a bigger kind of project, I will like also try to consider other metaphysical views. It's not like I want to force string theory to defend trope theory. I mean, I can start with that, see how far I can go, what I can reach, the problems which have already shown up, but I don't want to force physics to say something about metaphysics. So yeah, I will definitely consider also the abstract approach, so universal approach towards properties, and to see whether this can be applied to string theory, or if string theory can be used in order to defend also the other approach. If I have to think about this project as a bigger kind of project.
I mean, this is why I quite liked Claudio's comments, because it's, to me, this is a sort of a little bit more open-minded. It's not as if we hold fixed trope theory and try to find the right physical theory to support it, or that we hold physical theory firm and then try to match it to some sort of metaphysics. But instead, we're kind of exploring how stuff goes together, what new problems arise when we look at, you know, the mereology of bundles in string theory. All of a sudden, you know, completely new kinds of challenges and problems arise, and that in itself, I think, may be a very rewarding and interesting and enriching project.
Yeah, exactly. Yeah, I would like be more open-minded rather than force physics to say something about our metaphysical theories.
So I think Al.
Yeah. So thank you for the talk. I had just a curiosity, but it's symmetrical to Chris' comments. I mean, string theory is peculiar because it's not just a theory of quantum gravity, it's more a theory of everything. And that's the reason why some people don't really like it, because they think it's difficult to have some experimental outcomes that will ever confirm it. And now we have some approaches to theory instead of quantum gravity. And I was just curious about why did you choose string theory rather than loop quantum gravity? Just curiosity, it's not.
Well, I know nothing about loop quantum gravity, so that's basically the main reason. Yeah.
That seems. Yeah, I mean, so the suggestion is like, I mean, you don't need to fully study them, but I mean, be aware that string theory is quite not problematic, but it's not really as like as it were 30 years before, if I'm not wrong. Right. So just be aware.
Yeah, I know. I mean, for example, the only thing I know about loop quantum gravity is that it doesn't postulate the 10 extra dimensions, if I'm right. But yeah, that would be definitely like another path one can endorse while working on this kind of stuff, of course.
Thank you.
Good answer.
Do you mind going back to the slide in which you had the various possibilities of field theory and
Yeah.
because I don't know much about the subject, and I had just a question about what you said there.
So this slide?
Yeah, that one. That one. About Campbell's theory. Because it seems to me that just hearing what you said, the Campbell's theory has an advantage in that it seems to me that it is the only one that can give an account of how you can have, say, space-time points or space-time as a bundles of tropes. The other ones, you say that particles are bundles of tropes, but it's not clear how you can, whether you have to postulate also space-time points as individuals that are not bundle of tropes, or how you can account for that. On the first view, I mean, I can kind of imagine how that would work if you have just a classical field theory and you have the potentials. Then you can imagine that the value of the field are like tropes. They look like quantities. So you can say that 1 volt here and a bundle of that and something like that could constitute that point. So if you have something which is spread out almost everywhere, you can recover the points. But if you're not realist about the fields, then it's not clear to me how you can recover space-time in any form, or space-time points in particular, in another approach. If you're abandoning fields, I had the impression that your solution, tell me if I'm wrong, was supersubstantials. The idea, well, what if I identify space-time the material objects? If I can treat the material objects, then I can get space-time.
Yeah.
I don't think that would work, because on supersubstantials, as I understand it, it is the view that material objects are regions of space-time, or they supervene on space-time. But not every region of space-time is a material object. So if we need these regions of space-time which are not material objects, it's not clear that this by itself will allow you to recover them. So my question is, are you sure that you want to dismiss, Campbell's type of approach? And if you do, how do you think that you can recover space-time on your trope view?
Yeah, yeah, that's a very interesting question. I don't know, maybe because you said that, I mean, you're right, not every region of space-time can be identified with material objects, but maybe if we endorse Campbell's view, we might simply say that like the field value is 0 where there are no objects, where there are no material objects. This might be a solution. I mean, I don't want to drop Campbell's approach at all. We might take the advantages of this kind of approach because, yeah, as you said, supersubstantialism doesn't say that for each region of space-time we have material objects. Even because, I mean, our universe doesn't work like that, I think. I mean, there are...
Sorry. So that's exactly what Schaffer says. Schaffer says that, and actually has a... So don't dismiss it. Schaffer says there's two versions of substantialism, right? It's one is restricted, the one that Renzo had in mind. Every material object is identical to a region. There's another that also has the comments. Every space-time region is a material object. Don't dismiss it that, because all the arguments, all the metaphysical arguments in favor of that, the metaphysics one, actually work only for this view, for this radical view. So methodological harmony, I mean, you're radical anyway, right? You just might be, like you're thinking that Chris is a space-time region. You might think that even this guy is an object. Okay, then you're thinking that, when I say I'm friend with Chris, you're really saying that this space-time region is friend with this space-time region. You might as well say, no, well, even an empty one is a, and Schaffer makes that point. So there is a way of getting up. Schaffer makes this point explicitly, and it's a nice thing to show that If you don't have this field, for example, perdurantism, logical harmony, all these classical arguments, metaphysics arguments, unrestricted with the rational mind, which I thought was actually more plausible, do not go through. You don't get them. So if you want to reap the metaphysical benefits of supersubstantialism, you better go radical all the way. You just, stick to your guns and say.
And if I may add to that, it's even more, I mean, I think it's reasonable because it's kind of universalism about objects, everything is objects. It becomes quite equivalent to eliminativism about objects, because in both strategies, it's a very rough idea that, well, look, okay, anything is an object or nothing is an object, because the concept that we use they track some regularities or organization in the world, but it's for kind of arbitrary or conventional reasons that we select some regions. For instance, all the regions of space-time that look like people, I call that people, and so I'm realised about people, but if you're a super substantialist, Schaffer style, you just think that at the fundamental level there is just space-time and space-time regions. And all the regions are objects. It's just that we are interested. That's a subset of those objects, or maybe should use neurology, some specific parts of the cosmos that look like people or chairs or tables. So it might seem radical if you are not really immersed in the world of Schaffer, but if you get in, I mean, it seems quite natural to defend that anything is an object. I think.
I'm going to write Schaffer as well.
Just maybe a follow up after I think the problem I was raising and why I was inviting you not to dismiss the field view is that remains, because what I was objecting is not that if you assume space-time not as made of tropes but just primitive, just assume space-time, then you can call a material object whatever you want. But the point is the question was how can we give an account of space-time as made of bundles of tropes? And it seems that your strategy was, well, I have an idea of how to get strings or particles on the other views, and then the assumption was if I have supersubstantialities, then if I get particles, then I get space-time for free. And this I don't think would not work. So the promising idea was if I have a field theory, which I have fields which are defined everywhere, then probably if every instantiation of a field value is like a trope, then I can get space-time. I mean, this is not obvious, because I assume that I can understand why a scalar field, the value of a scalar field would like tropes. I'm not sure that the metric field, in the case of Schaffer, or an operator valued field, is that a trope? I'm not sure. But it seems at least that Campbell's view has this advantage that I can see more easily how to recover space-time. If you need it, if you need the Calabi outline or whatever.
I mean, it would be interesting also to, I've just thought about this. I don't know if it's possible to do so, but for example, if we remember the, because if we look at forces and we conceive them as like particles, so particles generate forces, we could conceive forces as fields. Forces are fields in a certain way. So we can derive from that, we can conceive them as like the fundamental tropes, and this would be maybe an approach more similar to Campbell's view. So yeah, it's worth considering his fields. You maybe update it with these kind of forces, and by conceiving forces as string theory conceives forces. Even though, here again there are some problems because, for example, we haven't reached the graviton, which is the responsible for gravitation force. So if we do not have, gravitation is one of the most important forces of our universe, and if we don't have this, we don't have one of the most fundamental forces.
Maria.
Yes. Okay. So thank you so much for your talk. This is all super interesting. I'm really excited to see what you do with it. And I also have a lot of questions about how this can work. So it's super exciting. But I have a question about, I guess, fundamentality, which is a dangerous word to bring up. But it seems like trope theory, and this sort of echoes some of the things that already been said. I'm sorry for that. But it seems that tropes become interesting or smart when we get to, let's say, the six space terms, when we get to a four-dimensional space. And especially when you talk about this, making no distinction between Calabi-Yau spaces and strings and vibrations, instead of taking these together as fundamental tropes, it seems like we sort of take some parts of these dimensions of strings theory says that there are, and then sort of make these the tropes that sort of somehow relate to our four-dimensional space. But it seems it's not until you take those six dimensions,
Yes.
that you get the tropes, right? And it's related sort of to the idea of concreteness and sort of just talks about like what is space and what is being, like what counts in space and these kind of things. But I do get this impression that the tropes seem to be only interesting in expressing things at a higher level than at this like 10-dimensional space, and this makes me. Well, it's going to be interesting to see how we can maybe bring that down, or investigate how that will work in a 10-dimensional space, and how if the strings or the vibrations are in fact tropes, how these relate to each other, if they are in different geometrical spaces as well. But I don't know anything about string theory. So.
Yeah, no, super interesting. Actually, this is one of the main problems because we have these 6 dimensions, and how do they relate with the extended dimensions in which we live in? I don't know. I mean, the intuition is that these 10 dimensions include the 4 extended dimensions, but yeah, it's not clear how we, or at least it's not clear for me, how we can get particles from these 6 dimensions we do not have access to. So yeah, that's a problem. But maybe I just have to go through the. I just have to investigate more about string theory to see exactly how this can work for a higher level dimensions. But yeah. Thanks.
I have a follow-up on that. So, I mean, there is a highly non-trivial question of what should be identified with space or space-time in string theory. And there's some work by Nick Huggett who tries to sort of articulate more fully or develop the view that's present in some physicists, such as Ed Witten, for instance. And Huggett argues that these, the Calabi-Yau spaces, or these apparently fundamental spaces in string theory, they're not what we should associate with space-time at all. What is space-time in a more, in a phenomenal way, connected to the space and time as we experience it, and perhaps by virtue of that also connected to the four-dimensional space-time of GR, is something that emerges as a result from these fundamental spaces in a non-trivial and interesting way. And if that's right, then, it seems as if you would be doing something else from standard supersubstantivalism or so, if you're sort of supersubstantivalist about the Calabi-Yau spaces, say. You have, in some mathematical sense, a space of which you are a substantivalist, perhaps, and but it wouldn't be obviously connected to, to physical space.
Mm-hmm. Yeah, exactly. Yeah, this is one of my main concerns because it's not clear. I mean, if we can obtain space-time, so in a emergentive sense, yeah, it could be interesting to show. I mean, how these properties, how these tropes can emerge maybe from these extra dimensions. I don't know.
Well, yes, maybe, you know, that they could emerge, and, you know, we could tell some sort of story along the lines you've sketched it at an emergent level. But then my question would be, well, what about, you know, the fundamental objects and properties? How should we think about those? Whatever those are. Maybe this weird quantum entities with quantum properties and quantum states and some sort of, you know, radically quantum theory of gravity and maybe everything else, who knows? What will we do there? How will we think about these structures at that level? Is our metaphysics going to give out? Do we need to have radically novel conceptions of what it is to be an object and what it is to be a property at that level? I mean, maybe so, but that would be a pretty radical conclusion if that's where we're going for. So, in general, I take metaphysicians to be involved in a project where you would certainly want to address the fundamental level of the physics. That's what we talk about, or I mean, among other things, not merely about the emergent stuff.
Okay. Yeah, sure. Yeah, I mean, it's definitely a direction to work on, because yeah, we want to address the fundamentals, not, I mean, yeah, how the fundamentals work and how we can get from that the general properties we all can see. But
Yes,
yeah.
absolutely.
Yeah, now that I'm thinking of it, I may have fooled myself. But, so suppose you really want to push. I'm trying to think what you should do here. So I'm doing the work for you, so keep buying beer.
It's good, you should encourage
Yeah,
it.
you should buy beer. So suppose you want to really be like parsimony guys, right? Just want tropes and mereology, and let the word be. That's kind of hard. But. So here's what you say, right? The vibration determines mass. So my guess is that so here's one way. Start with some property-like things about the strings, the shape, the topology. Fuse them to get a string, one particular string. The green one, the blue one. Now the problem that you seem to face is that now you have to give me the mass of whatever as a mereological fusion of those things. But this determines. So it's difficult for me to wrap my mind around the fact that determines there that the vibration determines the mass. It's a mereological relation. Because otherwise you need another relation, which is fine which is fine. But it seems that just with tropes and mereology, because I'm guessing that the vibration determines characteristics is my foot problem. So means like, if they move like this, they have a mass. If they move like this, they'll have another mass, right? This doesn't sound like mereological talk at all on the face of it, right? It doesn't sound that, this motion is part of mass. Maybe it can be done, but this would be the most straightforward thing to do, but it's a good battle to fight.
Yeah.
It's an uphill one.
Yeah, actually, I've thought about this, and I was kind of skeptical about these determinants, because we need to actually see how exactly does the vibration influence the characteristics we have of particles. I mean, how specifically does it work? For me, it's not 100% clear yet. I mean, we have this vibration, but how can we get mass from this vibration? All I can say is that it depends on the structure of space-time, but then again, of the dimensions, etc. But how specifically does it work?
So, if I may interject, I'm not a string theorist at all, but my understanding is the idea is that there's not an upstring and the down string, and the charm string, and the strange string, whatever, strange string, I guess. These different kind of strings, and on top of being a strange thing, say, that string does a vibrational thing and is closed or open, but because that would already mean that string has the mass of 104 MeV. It's all the same, it's one kind of strings, and these can be in different states, which are characterized by their vibrational and topological properties or states, as they're understood. And they give rise to the different kind of fermions and different kind of bosons and stuff like this. I think it's supposed to be something like that. That's the sense in which mass arises as a result of a string being in a particular state, because that state is the 104 MeV state. With that vibration, would it vibrate differently, then it would have been whatever 4.2 GeV state, say, or something like that. That's my understanding anyway.
Yeah, I think it's something like that. But.
So Maria was the first one, actually.
Okay, no, yeah, I will also discuss kind of along the same lines, because it seems that you need the strings to be somehow more like simple in a sense. If you make the story you do, you sort of get like this two-level trope theory, where you have tropes forming the strings or whatever the thing is here, which then forms the next level tropes, which then form particles, which seems a little like now it's a lot of layers all of a sudden. It gets very complicated, and then it's not obvious again that the bottom layer should be tropes, and in this way, collections of bundles of tropes anyway, and this is what you're saying, right? They're supposed to be more simple, complete entities in some sense.
I can see two advantages. So, an advantage of it's classical trope theory, right? It's really property-like entities, right?
Yeah.
So everyone, people that want to do like space-time out of tropes, they really talk. Oh, you have topological tropes, and you have metro, whatever that means. In this case, it would be. So, and this was just to give something that was not on the table, because the table was either the tropes are the strings or the tropes are the spaces. I don't even remember the names. There may be another option. The tropes are really the properties of the string, topological properties, shape properties, and so on and so forth. And in that view, you're completely right. Tropes are the basic. It turns out, interestingly enough, that string theory, the fundamental objects about string theories are not strings. Strings are built up, which is, I think, it's a fine metaphysical. Now, one thing that starting just with the strings, like Maria suggested, they might be nice, but please tell me if I'm really making a fool out of myself. Can two strings be, let's say, collocated on top of each other?
I guess so. I think that strings can.
Because I thought if they couldn't, because the beautiful thing about they couldn't, they could solve one of the greatest problems in trope theory. One of the greatest problems in trope theory is that, given that tropes can be collocated, how do you know that not 72 tropes of the same black there, rather than 36, rather than 1? Either you think it's a brute fact, or you cannot even appeal to kinds, because otherwise it's going to be universalist. If the strings by any chance, right, were not able to do that for physical reasons, then you say, well, it's physics that tells me, given that the basic tropes are strings, and the strings cannot be collocated, physics would have solved a classical metaphysical problem, which would be super nice.
But, as I have understood it, when two strings are put together, they like create a new string. It is like the two strings never existed before. I don't know, I'm not 100% sure about this, but
so
maybe.
That, I'm not also not 100% sure, but my understanding is that there's, I don't know whether two strings can remain numerically distinct and be co-located in target space, not in actual physical space necessarily, So it's not even clear whether that's real location, what we mean. That I don't know, but I do know that they can certainly fuse. So two strings can meet and join and become one. That's certainly possible. But I don't know whether it's necessarily happening if they are co-located in target space.
What does it even mean two things can become one? That's so weird. That's so weird. It seems like it's impossible, like in just B model logic. Like distinctness implies necessity of distinctness. Just in B, like just a very, very weak model logic.
It's a fusion of
fusion is fine. Like there are three things now.
There's the first thing and second thing,
Exactly.
the fusion of them.
That's exactly right. That I can make sense of.
Yeah.
I cannot
But-
make sense of two things becoming unless
So-
metaphorically.
Maybe it's just,
You already had this
maybe physicists do speak metaphorically, but this is what they constantly do at CERN. I mean, not even at string theory, we can go into particle physics. You have the decay processes, for instance, they look at. They bang particles onto one another so that out of two, they make a gazillion particles, a particle shower that then erupts. So out of two things, these two things cease to exist and in a way are replaced now by 27 particles that they detect.
And none of them is identical to the first one. That's fine.
So these two things in a way have become the 27 things.
It's just that the things are not real, they're not individuals.
Sorry?
It's just that the things are not real, they are not individuals. It's just an effective description of what's going on.
Sure, yes, that's right. I think that's what it is. And physicists often speak effectively in that way, and in that same way, you're supposed to be thinking of two strings incoming in your particle accelerator or whatever, and fusing to become one. Or splitting at the effective level. That's what's happening. But
So,
anyway, you had your finger up all the way.
it was a follow-up on the previous stage of the discussion, but I think it relates to many things that have been said. It's one thing that was a bit missing in our discussion is the fact that it's natural to think of string theory in terms of the field theory. And so one hypothesis would be to look at Campbell theory and see how it fits naturally or not with string theory. So my explanation would be to say it will work almost the same, because string theory is basically it's the same philosophy as quantum field theory. It's just like very roughly you replace the one-dimensional point particles by two-dimensional strings, and for reasons of mathematical consistency, introducing the relativistic effects, you have to add further dimensions. But very naturally, you can think of that as a kind of fields living on space, and it's a bit tricky to understand what are the spaces, what are the fields. But many issues of ontological interpretations are already there in quantum field theory. And there, of course, there is this huge debate about whether objects exist or not in quantum field theory. And you can translate that to string theory. And there I think the most standard view would be to say that, strictly speaking, strings do not exist as objects. They exist as quantum fluctuations of the field, something like that. So I guess at least we should distinguish between two ways to look at string theory. One is to think of it in terms of, so you have objects, the strings, and of course those objects cannot be tropes because they are objects, but you should think of them as either bundle of primitive properties or as substratum having properties. Those properties are topological properties and vibrations, basically. And so you say you have this model, but that's one way to look at the picture in terms of objects, really taking seriously the category of object in string theory. Now the other way to look at it is to say, well look, it's a way to look at what's going on, but in fact the ontology is more akin to what we try to build to make sense of the ontology of quantum field theory. And of course the ontology is not clear in string theory, just as it's not clear in quantum field theory. We don't know for sure what the ontology is there. But what I'm trying to say is that if we want to build some metaphysical models for making sense of what's going on in string theory, I think that there is a very appealing option in terms of fields. And if that's the case, it would be natural to look at the literature on Campbell, the field of tropes that you mentioned.
It's actually, thank you for the suggestion. It's exactly as you say, because string theory is in a certain sense opposed to quantum physics, because there are no point-like particles. So there are strings, and this vibration of the strings only like intuitively seems way more similar to a field rather than a point particle if you think about a vibration. So maybe we can do work in that direction. So maybe we can actually conceive string theory more as a field theory. I don't know. We should look at what actually physics says about this kind of stuff.
I mean, there would be a nice argument if you can show that. I mean, you cannot make sense of objects in string theory, so it suggests a particular sort of trope theory.
Yeah.
It could be an interesting result or hypothesis.
Yeah, and also I don't think, because, for example, one of the objections to Campbell's theory was that you cannot precisely locate fields. So this was one objection, but I think that maybe we can drop this. I mean, we do not need actually to spatiotemporally locate
I agree. It
tropes.
doesn't strike me as a good objection, to be honest.
If I may return on again on I'm not talking about Campbell's theory, but
Okay.
and if I may insist, I remember when you explained the objections, but I have not fully understood them, so I just wanted to ask you maybe if you can explain them better. So the second one is that if we accept the field theory that fundamental objects are approximately fields, and then we want to give a trope theoretic account of fields, then we have the problem that we cannot locate in space-time the tropes. And I'm not sure I understand why, because to me it seems that it's exactly on this view that we can say account for what a space-time point is as a bundle of tropes, so as a bundle of field values. And then I assume that you will have to have some primitive geometrical relations between space-time points in this sense, understood as bundle of tropes. But so why am I wrong? Why is there a problem about the space-time location of tropes on this view?
So I think that the problem with field theory is that, I mean, you have fields and you cannot precisely say where the force of the field stops to, I mean, can I use, okay.
I hope it works, yes.
Yes. So if you have a particle, you can maybe locate it within a Cartesian plane and you say, okay, it's here and here. But with fields, as far as I have understood it, you have more something like that. I mean, think about gravity. So gravity extends, and the only thing you can say is that here gravity is stronger, because here you have like the particle or the object or whatever, and here is weaker because you are farther away from the object you are considering. So I think that the objection has to do with something like that. I mean, if you have the trope, where is exactly located? It's like in the center of the field, because there the force you have is stronger, is at this place of the field. I think the objection has something to do with that.
So I think I understand now, but I think there is an ambiguity between two strategies you could take. One is to try to have the field as an object and conceive of that as a bundle of tropes. And that I think doesn't work. But there's another conception of what a field is, which is just a distribution of properties of space-time. So you have certain bunch of properties, and then you have a distribution of those properties in space-time. So the field values are the tropes, rather than the field being a value of tropes. And if you have that, then I don't see why this objection applies. I think you see. So of course, if Campbell is saying the other thing, that you have these objects, the field, which is made of tropes. Of course, I see why the objection applies. Where is it? What tropes is it made of? I don't know. But if you think that another standard conception is to think, what is a field? It's a distribution of properties at space-time points, so properties of the space-time points. Then you can apply the bundle theory to them, to the space-time points, using the field values as the tropes.
Okay. Yeah. Thank you, by the way.
I mean, this has been done in the literature. Meyer Kuhlmann, there's a guy in Germany that did that for quantum field theory, and then an Italian philosopher has actually responded, Emanuele Rossanese. So there's a nice debate about them.
Okay.
In Studies in History and Philosophy of Modern Physics, exactly about this point.
Okay, thanks.
Baptiste, do you want to ask a 15th question? Or
To be honest, I feel tired, so I'm happy to.
I'm not tired, so guess about what.
In fact, I want to ask my question.
Yeah, go on.
I'm joking.
Which year do you want?
Well, guess about what I'm asking. So I'm obsessed with this narrow part of your presentation. I apologize for that. So another thing you said for ruling out the field view.
But I'm not actually ruling out the field. The objections I've mentioned are not mine objections.
Right. Okay, well, yes. So you mentioned some problems with it, which seems to motivate looking for alternatives. Maybe that's.
I mean, I've just mentioned it because it has been done in the literature, and otherwise I couldn't have explained you why Simons and Morganti and also Loffredi seem to take another path. Or at least this is to show that there are other options to field theory.
Mm-hmm.
But yeah, go on.
No, okay. Because I just heard them, and I wasn't sure I was convinced by them, so I wanted, to ask about them. But of course, maybe you don't have to necessarily to reply to them if they are not stuff you're endorsing. But I remember that you said that one reason to move away from the field ontology was that there are mathematical problems with field theory. And then the question is whether are you referring to quantum field theory or to classical field theory? Because because it seems to me that if you have QFT, you have this debate about whether you should understand it as in terms of fields as being the fundamental ontology, or particles being the fundamental ontology, but whether you choose one or the other will do nothing with, say, the mathematical problems with the theory. At least it doesn't seem that, say, moving to a particle ontology will somehow solve the mathematical problems. So I wasn't sure, that citing the mathematical problems of QFT was much of an argument against a field ontology in favor of a particle ontology, right? So I don't know, maybe if you're just citing that there are these objections in the literature, if you know the people that are making them in mind.
Yeah, I actually don't know how to answer to your question. Yeah, I don't know. I have to do further research on that.
Mm-hmm.
Yeah.
I think that you're quite right. There is a general problem with the mathematical foundations of quantum field theory, which are supposed to be, if you're of a mathematical mind, somebody who likes to think rigorously and to sort of establish the theory in some sort of formally sound foundation, like an axiomatic theory, it's a disaster. It's so unrigorous it's actually outrageous that quantum field theory works so well as it does. But you're quite right to point out that's a problem regardless of what sort of interpretation we adopt or whether we think of it in terms of saying something about fields or about particles or whatever. That's a general problem. That is supposed to be mitigated if we move away from standard conceptions of quantum field theory or formulations of quantum field theory to perhaps some sort of algebraic formulation or axiomatic quantum field theory, or some project where we try to build up in a mathematically rigorous way a theory that is in some sense in the neighborhood of these successful theories. But it may not be equivalent because we will not have a sufficiently rigorous way of translating between these theories, so who knows. But something like that is the project. But that seems to be somewhat orthogonal to the interpretive questions. Maybe, however, once we have, if we ever get to it, a sort of a rigorously formulated quantum field theory, then perhaps this will give us further insight into how to think about that theory. I mean, hopefully, really.
Yeah.
I'm sorry, it's a different question, so if you have to...
Yeah, no, of course, since you're almost all the time, it's spoken so much.
Okay, thank you. Then I just, it's a very minor comment actually. So, I think I had the impression that you were sort of grouping Aldo Freddi with Simons and Morganti on this slide as well, as giving this sort of a relational spin on the particle as bundle of tropes story. And I just wanted to point out that, well, correct me if I'm wrong, but as far as I understand the paper, Aldo Freddi is actually neutral about what sort of physical system we are talking about. So the idea is just to reduce physical systems of any sort to bundles of tropes, where tropes are given by physical degrees of freedom, and, well, or to be more specific, the values these degrees of freedom can take. And so I think that's an approach as well that is neutral, at least prima facie, between a field ontology or a particle ontology.
Okay, thanks. Yeah, I guess you're right. I mean, yeah. But I wanted to answer to you another thing, that maybe the objection to campus approach, so that says that it's not mathematically rigorous, maybe it's a general objection against field theory. So not specifically on what he has done, field theory and tropes, but maybe it's a general objection against field theory. Exactly, because it's not mathematically rigorous.
So rather than for some future theory, the fundamental theory, something like that.
Yeah, I mean, the objection is an objection against field theory in general. So field theory is not mathematically rigorous, so we shouldn't use it in order to defend a trope theory.
So one possibility, one thing I had in mind that would work is that I know one paper and one person, so it was Dustin Lazarovich in Lausanne, who were working on classical field theories and was considering that it is well known that they are inconsistent as well. There are also inconsistencies in classical electromagnetism, right, if you look very, very closely. And his suggestion was precisely that you should start work on that and prefer an action at a distance theory rather than a field theory. He was working, I think, on the Feynman-Wheeler theory. I think I understand what he was talking about better in QFT, which not at all. And his whole project was, well, we should work on that, and then if we quantize it, we will have something better than what we have now, something like that. So maybe his idea was actually, if you have a particle ontology and a theory with action at a distance, no fields, and you work on that, and you combine that with Bohmian mechanics, maybe that's the route to have a theory that works. So, but it's a very, very idiosyncratic as far as I know point of view. So, but maybe it was that.
Thanks.
Okay, I think we're out of time. Please join me in